Hello and welcome to Donovan Evans Tutoring. I'm your host, Donovan Evans, and we are continuing our series where we aim to complete at least one question together per day. And it looks like today we're going to talk about kinetic friction, a little bit of the physics review. So let's see what we have in store. All right, so it looks like we have a 3 kilogram block on a rough surface that requires a 6 Newton force to move at a constant velocity. And we're looking for the coefficient of kinetic friction. Cool. Now, for any physics question, my recommendation to any student, to every student, is always going to be, if possible, can you create a force diagram for the situation? Or really a diagram in general. Physics is math applied to life, and in my opinion, if you can describe or create the setting for what's going on and put that into your own words and use equations to help explain what's going on or connect what's going along the way, you can see improvement in your understanding and application of physics. So let's go ahead and do that. Enough for me word vomiting. Here's my rough surface. I'm not an artist. And then we have 3 kg block. Cool. So let's start to describe this based on the force of things. Now, what's something that's very important in terms of understanding the force dynamic relationship here? When I'm looking at the constant velocity, right, that should be a force indication for us, right? This should let us know that our net force is 0, right? That should be an indication that our net force is 0. So why is that important? That's important because if our net force is 0, that means that the sum of all the opposing forces will cancel each other out. So north will cancel out with south, east with west, right with left, up with down, everything. Everything that is going in one direction in terms of force will have an equal and opposite force opposing it. So we want to keep that in mind as we are crafting this particular diagram. So first force, as always, we're on planet Earth. So we're going to say that we have a gravitational force, right? And we're going to remember that our gravitational force is always going to be equal to mass times the acceleration due to gravity. So in this case, since my mass is 3 kilograms, I'm going to multiply that by the acceleration due to gravity. All right, so obviously our acceleration due to gravity is more accurately 9.8 meters per second squared. But for the sake of this problem, we'll go ahead and just say that is 10 meters per second squared. All right, so that means that our force due to gravity in this case is 30 newtons. Great. And so since we were making contact with the surface, with this object making contact with a surface, presumably a flat surface. We're not going to go into details for that, but presumably a flat surface. So it means that all that gravitational force, all 30 newtons, is making contact evenly. And if doing so, that means that the Earth is pushing back with a normal force or contact force that is equal and opposite, right? Because again, we want a 0 net force in this situation. Cool. So let's keep it going. So we've now talked about a gravitational force and a normal force, but there's also an applied force here, right? An applied force, let's put it on this side and say that we're applying a force going this way of 6 newtons. Good to know, right? But again, the net force needs to be 0. So that means we need to account for the force that is associated with a rough surface, and specifically kinetic friction. So let's go ahead and account for kinetic friction going this way, right? I'll put a K there for now for the kinetic friction. Cool. So what is the kinetic friction force? So considering there's no other forces that are occurring at this moment or that we know of, that means that we have just this frictional force to oppose the 6 newtons that's applied. So that means that the kinetic friction has to also be 6 newtons, right? So the kinetic friction has to also be 6 newtons at the time of this particular problem. Cool. So what next though? What are we looking for? We are looking for the coefficient of kinetic friction, right? So we need an equation for that. So hopefully we can remember the equation for that. It looks like we got some information in the way. But the most important thing is the equation is that the kinetic force, or the um, force of kinetic friction, is going to be equal to the coefficient of kinetic friction times the normal force, right? So let's keep that in mind as we move forward in terms of solving this particular question. Okay, so here we'll go ahead and keep in mind the equation that we have in place. So the the equation that we are going to be working with is going to be our kinetic friction force. It's going to be equal to our coefficient kinetic friction times the normal force. As always, my recommendation is going to be go ahead and list out those variables, right? Even if off to the side, I'll go ahead and list out the variables and say, here, okay, I have a kinetic friction that is 60 newtons. So that force is 60 newtons. Do I know my coefficient? I don't, and that's okay. What's my normal force? Well, according to calculation, is 30 newtons. Perfect. So we have one equation with one variable that's unknown. So let's go back to the equation. So I can now replace this 6 newtons here. So I'll put 6 there. The coefficient of kinetic friction, that'll be unknown. And then we'll say that's times 30. Cool. So from there, I'll isolate for the coefficient of kinetic friction by dividing by 30 on each side. All right. And so hopefully we're recognizing that that simplifies to 1 over 5, and 1 over 5 simplifies to 0.2. So this would be our answer for this problem. Okay, so this would be our answer for this problem, and that would be it. All right. So just a note, want to make sure that I'm leaving you with a little bit of background information. And the goal is to go over just one question each day, but just a little bit of background information in terms of the distinction between kinetic friction versus static friction, right? So kinetic, as the name implies, means that this friction that is going on while an object is in motion, right? Versus static friction, as the name implies in terms of static, that means that this is going to be friction that is applied before, right, or while an object is in motion, or while an object is at standstill. So the way we like to think of it is that the static friction is holding an object back from movement, and then once that force is overcome, then the object will go into motion, and that will then reduce to a kinetic friction that will hinder ongoing movement. So I just want to make sure that I offer that distinction, and they actually have similar equations. We can say really the same equation in terms of the force equation. It's just the coefficient times the normal force. But I'll do another question relating to static friction in the future. So that'll be it for today. Thank you as always for tuning in. If you like the information that you see here, please like, share, and subscribe. And please, if you have any questions relating to this or any of the other topics that I cover, feel free to contact me. Happy to help. I hope all is well, and I hope you have a great one.